Problem number 6. We're asked to evaluate the integral between 4 and 15 of 11 times f of x minus 6 dx for this function right here. We've graphed y is equal to f of x between 0 and 15. So I also have to point out here, they're shaded in areas here. So this bump right here has area 13. We're given that. This, curvy triangle-ish region down here has area 8. Okay, how do we tackle this? Well, whenever we start worrying about integrals and definite integrals and stuff like that, and the connection of area under curves, well, the catch here is that we need to worry about signed area. So this picture tells us the following 2 facts. It tells us the integral, so let me do the easier one first. The integral from 6 to 15 of f of x dx, it's going to equal here 13. But the integral from 4 to 6 of f of x dx is going to equal negative 8. Why is that? For definite integrals, if you have area under the x-axis, it comes from the negative sign. We care about signed area, as we say here. So this picture gives us these 2 definite integrals that we'll care about right here. And so what I want to do is then observe that the integral, we can use these 2 facts here. What's the integral from 4 to 15 of f of x dx? It's going to be this plus this, negative 8 plus 13. It's going to equal 5. So there's 13 units of area above the x-axis. There's 8 units of area below the x-axis. The total net signed area is 5. Okay, so now that we've got all of that set up right here, we can go back and actually worry about evaluating this integral. I'm going to rewrite this as 11 times integral from 4 to 15 of f of x dx minus the integral from 4 to 15 of 6 dx. Okay, what's going on here? This is just this. So 11 times 5 minus 6 times, when we integrate the constant between these bounds, it's just the difference of the 2 bounds here. So this is going to be 55 minus 6 times 11. 55 minus 66 is negative 11. Okay, problem number 7 here. Consider this integral below. Evaluate this without using Riemann's sums or the fundamental theorem of calculus. Hint is to try graphing the integrand here. Okay. Y is equal to the square root of 9 minus x minus 1 squared. Let's try plotting this. Squaring both sides gives us y squared is equal to 9 minus x minus 1 quantity squared. And moving the x term to the other side, we have x minus 1 squared plus y squared is equal to 9, and 9 is 3 squared. So we should recognize this. This is an equation of a circle. The circle has radius 3, because we see the 3 squared right here. And the center is at the point 1, 0, because this is x minus 1 squared plus y minus 0 squared. So this is the information that we need here. So let's draw that. Center at 1, 0. So there's the center, radius 3. So 1, 2, 3. 1, 2. Okay, so it goes 3 units in that direction, 3 units in that direction, 3 units down here, and 3 units over here. Okay, so here's our circle. Now, let's go back and take a look at this. What are the bounds here? The bounds are running from y is equal to -2. That's right here. Sorry, x is equal to -2 to x is equal to 1 right here. We're being asked for the area under the curve here, between x is equal to -2 and x equal to 1. It's a quarter of a circle here. So what do we end up with? The area of the entire circle is pi times r squared is 9 pi. So the area of a quarter circle is going to be 9/4 pi.